6.6 is about trapezoids and kites. Now this talks about if a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So if TRAP is an isosceles trapezoid with bases RA and TP, then angle T is congruent to angle P, and angle R is congruent to A. You can tell by the markings up here. Again, base angles, there's two sets, T and P, R and A. Those are base angles. Why? Because our bases are both RA and TP. Even though TP looks like a base, RA is also a base. The things on the side there, RT is what we call legs. Okay, so problem 1 talks about finding angle measures in trapezoids. Okay, CDF is an isosceles trapezoid. The measurement of angle C is 65 degrees. What are the measurement of angle D, angle E, and angle F? So when we're taking a look at these things, we know that since angle F and angle C are base angles, we can say that angle F equals 65 degrees. Why? Because it's equal to angle C. They're both 65. We know that consecutive angles in parallelograms and everything else are going to be supplementary. So I can say that measurement of angle C, which is 65 degrees, plus the measurement of angle D is going to equal 180 degrees. Go ahead and subtract 65. You end up with measurement of angle D to be 115 degrees. Well, since D is 115, we have F to be 65. We can say angle E also angle equals 115 degrees. Theorem 620 talks about if a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. So again, we had base angles congruent, now we've got diagonals. A to C is congruent to BD. And also, if a quadrilateral is a trapezoid, then the midsegment is parallel to the bases, and 2, the length of the midsegment is half the sum of the lengths of the bases. So in a triangle, the midsegment was half the base. In a trapezoid, the midsegment is 1/2 of the sum. So 1/2 of TP plus RA. And that's going to become important as we go on here. So in problem 3, they want to use the midsegment. They talk about QR being the midsegment. And again, set it up. I said this with the triangles. I'm saying it again here. The midsegment, which is x plus 2, equals 1/2 of the sum. So the top is 4x minus 10 plus the bottom, which is 8. So 1/2 the sum. So we're going to end up with x plus 2 equals 1/2 of, let's combine inside, negative 10 plus 8 is 2. So 4x minus 2. Again, you could do a couple different things. You can multiply by 2, you can distribute the half. Because it's going to work out, let's just distribute. X plus 2 equals 1/2 times 4x is 2x. 1/2 times 2 is 1. Now let's go ahead and solve. Subtract x. I get 2 equals x minus 1. Add 1, I get x equals 3. Okay, so that's what they wanted, was the value of x to solve for my midsegment. 622, they're talking about kites. If a quadrilateral is a kite, then its diagonals are perpendicular. So ABCD is a kite, and if you look, let's take a look. AD is congruent to AB, and DC is congruent to BC. So you need to see that as far as properties of kites go. And so we also know that our diagonals are perpendicular. So in problem 4, they talk about finding angle measures in kites, and they want to know what angles 1, 2, 3 are. So again, let's take a look here. We know that the measurement of angle 1 is going to be 90 degrees. Why? Because we just talked about perpendicular diagonals. So measurement of angle 1 is 90 degrees. So again, if you look where 152 degrees and 2 is, that's a triangle. So our old triangle is back. So we can take measurement of angle 1, which is 90 degrees, plus that 52 degrees, plus 2 is going to be angle 2. We'll do that so you can see the difference. Is going to equal 180 degrees. Okay, so we add those two together. That's 142 plus angle 2 equals 180. Angle 2, subtract 142. Angle 2 is going to equal 38 degrees. So we get 90 degrees here for 1. Angle 2 is 38 degrees, and angle 3 right there, because of congruent triangles, we can say that angle 3 is equal to 52 degrees as well. So there's angle 3, there's angle 2, there's angle 1.